So the exponential function f of x equals 1066 e to the 0.042x models the gray wolf population of the western Great Lakes f of x years after 1978. Project the gray wolf's population in the recovery area in 2012. Now these are old examples, by the way, in case you didn't notice, okay? We could have changed it to any year. But let's see what we think what they thought the population was going to be in 2012. So they gave me the equation there. So let's go through our variables. What does f of x represent? The population, okay? So the population of the gray wolves in the western Great Lakes is f of x. What is x? X years after 1978. Be careful on that because they got you. It's not just the number of years, it's the years after 1978. All right, so they gave us this equation. Now, it says project the gray wolf's population in the recovery area in 2012. So what about after there? Project the gray wolf's population. What is that, x or f of x? That's f of x. So that's what we're looking for. So the 2012 has to do something with x, right? So in 2012, what is our x going to equal? Well, how would we find that? Because x represents what again?
The years.
The years after 1978. So how many years after 1978 is 2012? How'd you get that? You subtract them. Good. So 2012 minus 1978, and you're right, it is 34. So we're just going to plug in x is 34. All right, so over here we have what we're going to do in our little calculators that we use in here. If you have a different calculator, it may be a little bit different. All right, so you had to do your exponent part first. You had to hit the equal sign to get that answer. So I gave you some number there, and you're going to hit second and the ln to get your e to the x. That gave you an answer, then times the 1066. And so it tells us that f of 34 then is equal to 4,000, help me, 445.59. So what is the population going to be? Can't have 0.59 of a wolf, can we? So do we round up or down? Do we have a full wolf? Don't have a full one, so round down.